Hi, everyone. I recognize some of the names. I know some of the people. For those who don't know me, as before, I'm an anesthetist and intensivist at CMJ in Johannesburg. I've had the fortune of being able to play with a few of these devices over the last couple of weeks, just to get a feel for them and give some feedback. So I think I may have had a chance to experience them a bit more than you who have had devices delivered. So I thought I'll just go briefly through sort of setting it up and using it. But what I would say is, if you really want to get a feel for it, the first thing you should do with the device you have is strap it onto yourself, get a feel for the flows, how it feels to breathe with it. It also makes it incredibly simple then when you're trying to set it up for a patient to figure out how you need to set it up. I know there have been some concerns over the ability to measure the actual flow, measure the FI that you're giving, and around humidification, and hopefully we will touch on some of them as we go through it, but obviously questions will be welcome. So I don't know if you can see that well. The device itself, you should have this exact one made by SaberTech, which is essentially the UCL device. The only thing I've done to it, just to make a little bit of the explanation easier, is in the off position on the knobs, I've put a little bit of tape onto the flow control knob, and on the FI knob, I'm just using the small screw that's in it to determine how many turns we're going through, just to give you an idea of how far to go, and equally how sensitive the turns are. And it does correlate relatively well with the gas flow and the mix that you're giving. So pretty simple to set up. It's pretty much plug and play. With your flow control and your device in the off position. As far as circuits, we've got two pretty much to go through here. It's a mess. I've got the one provided with the device that you would have gotten. So this is pretty much an exact setup as UCL had. It's a dual port mask with an anti-asphyxia valve mounted in it. Standard 22 mil hosing, viral filter on the inlet, just to make sure your entrained air is pretty clean. And this is then the pressure relief valve. And then on the outlet port here, we're going to have, again, viral filter so that we're not contaminating the environment, and the PEEP valve that we're going to use to select therapy for. So pretty much, once you're connected, the most important thing is potentially going to be to make sure that you've actually got a decent patient seal before you even initiate flow, because we've got both an anti-asphyxia valve on this mask, and the device itself acts as an anti-asphyxia valve. You can apply it with zero flow and make sure that you've got a good patient seal. I'm not going to stick it on my face now. And then once that you're happy with that seal, the next thing will be to start initiating flow. I'm going to change the masks just for a second, because I've got O2 and flow meters hooked up to the other one, just that I can at least show you what sort of flows we're getting with each of the settings. So the one I've got is just, I've got a standard uniportal mask with HMEF T-piece. I've got a flow meter sitting in here just to give you an indication of what flows we're getting. And I do have a side stream O2 analyzer attached. I'll see if I can actually show you the readings. It's a bit tricky with what I've got here. I might have to read it off for you. So the idea is going to be attach the mask. And with zero flow, you'll watch that I'm able to breathe easily. So it is easy. I'm not turning blue, as you can see. So the next step is going to be open there's an on-off switch. We're going to open that fully, and then we're going to slowly increase the flows until you get to patient comfort. What I had found is setting a PEEP value of around about 5 to 8 to start with, and then slowly increasing the flow until A, it's comfortable to breathe, and B, that you can hear any anti-asphyxia valve cycling or entrainment through the side port. You don't want it to be very prolonged, but at peak inspiration, you should be hearing a little bit of entrainment. If there's little to none, you're probably overdoing your flow a little bit and you're just wasting gas. So I have marked the flow control knob. I'll show you afterwards, but as we open it through 360-degree turns, it does correlate relatively well with the flow that you're getting. So let me just open it. So the first setting I've done is I've opened it through one 360-degree turn. What you'll find there, the flow that you're getting is a little bit under 20 liters per minute. Obviously, it's a little bit harder to breathe because the vast majority of the air is now being entrained. And the FI that I'm getting sits at around about 30% to start with. The lower your flow rate is, it does tend to climb over time at the very low limits. If I go through another 360-degree turn, so the measured flow there is sitting at around about just under 40 liters per minute. My oxygen-enriched mixture is still closed completely, but what you'll find is the bottom end of this device is around about 30% to 32% with the O2 entrainment, the O2 enrichment knob turned off completely. And if I go through another half a turn, we now jump up to just over 50 liters per minute. And I think it's probably almost impossible for you to hear, but what we're getting at this point is that I've actually got almost no entrainment through the anti-asphyxia valve. So this, for me, sitting, comfortable, quiet breathing, it's way more than I need. What you do find if you try it on yourself is as soon as you've got it on, you're getting a bit of flow and you're breathing with that PEEP and the CPAP, the tendency is to take much bigger breaths than you normally would at rest. But again, that's with a healthy, uncompromised lung, or at least I hope. If I start enriching the oxygen now, because I've pretty much set more flow than I needed, if it was a patient working a bit harder, you might need to go up a little bit more on the flow. But I'm going to slowly start enriching the oxygen supply. If you can see, the side stream analyzer, we're sitting at, it was at 32% with zero flow, with zero O2 enrichment. I'm going to slowly enrich it so that you can see. I'm going to open the O2 enrichment knob slowly. It is incredibly sensitive. So the one thing you'll notice is through the first quarter of a turn, then the next quarter of a turn, and the next quarter of a turn, you're going to see quite significant jumps up in the FI. So the idea there is to be gentle and cautious. But let me see if I can get this a bit closer so that you can see. Just so they can. If you got it there. All right, so if you can just watch the ET and FI in the bottom corner there. Okay, so that's a quarter of a turn open. We're going to go another 90 degrees. So we've gone from sort of 38 to now close to 50%. If I go another 90 degrees, more or less. You'll see there we stabilize at about 60%. And if I go through another quarter of a turn, so there you'll see we stabilize it close to 80%. And if we now open it to full through another 90 degree turn, it starts approaching 100%. All right. Thanks. Sorry, I like that next quarter takes it to closer to 90%. So it is quite a sensitive device. It's incredibly easy to set up. It's easy to use. Before taking the device off, you just need to turn the on-off switch to off. So then you reduce the amount of aerosolization. I've worn it for at least 45, 50 minutes at a time. With an HME, I haven't found any drying of mucous membranes. It's been comfortable. And I haven't found with the HME and for the air to be a problem. From the experience with the UCL guys, they did use the dual port mask. So obviously a completely dry circuit up until now. They didn't really experience too much in the way of drying of mucous membranes, provided the patient was kept well hydrated. But what they have noted is that were they to start this again for a second peak, they would also aim to have some sort of humidification in the circuit, whether by HME or active. The only problem with the active humidifier is then you lose the ability to filter your exhaled air. I don't know if there's any questions in the meantime, anything that I may have forgotten out or left out.
Just a note that they shouldn't be closed too long.
Does anyone have any questions?
I'd like to.
Yeah, please go ahead.
Hi. Yeah, sure. So, Ollie, the one problem with humidification, I think that all our flow is going to be vast majority unidirectional down these circuits. So I think in this configuration, I don't think that HMEs will help much. I think if we're going to get a lot of humidification, we either need to look at water bath humidifiers, or possibly we could do something with nebulization and saline nebulization or water nebulization.
So with
But yeah, in CPAP configuration, I'm not sure how crucial, as the London guys' experience was, how crucial humidification is.
yeah, so in the single port mask, your flow is bidirectional across your HME, so you do retain the moisture, as we would with HME use anywhere else. If you've got the dual port mask with you, it is unidirectional flow. You're not going to get active humidification, but so, I mean, they have the greatest experience with that. They didn't find too much of a problem with the dry circuits, except in the small subgroup that they ended up sticking a tube into. They did notice that there was a little bit of inspersation of some of the secretions. But the patients that tolerated the CPAP well and stayed on CPAP therapy were fine. They rested them. They made sure they were hydrated. They had something to drink intermittently. They didn't experience too much in the way of problems. But that's why we, certainly from my side, I think the uniportal setup is ideal. It's probably the thing that we all have access to easiest, is a simple uniportal mask, HME filter, T-piece, and a PEEP valve, and you're good to go.
Sure, thanks very much. And then just an interrelated question. I think this device would match very, very well with the hood technology. And I know there was some previous discussion about hoods. It would be very nice if we could find a way to get hoods.
Yeah, agreed. The hoods would be great to have. I did get the chance. I was lucky enough to be able to try one of them out. Obviously not for everyone. There are some people that feel a bit claustrophobic. My personal experience was very comfortable to wear, just a little bit on the noisy side. Previously, a couple of years back, we trialed the StarMed one. This is a hood. The one I tried here now was one sourced via a local company they imported from overseas, from the US. But again, very, very comfortable to wear. And I think in the subgroup that have poor mask fit, elderly patients, edentulous, it was great. It was very, very comfortable to wear, very simple to take on and off. So if we do get a chance to access them, we'd definitely jump on it. And certainly these devices, the UCL, well, any of the devices are capable of sufficient flow rates to make sure that a hood is safe. As soon as you get above around about 30 liters per minute, the CO2 washout is great, and there was almost no rebreathing.
Only for children, will these masks, what interfaces would you have, and how would the humidification work for the little ones? What would be the smallest?
How big a kid?
Got children, well, they can be from 0 to 12 years, so they can be from 3.5 to 20 kilograms.
So look, my experience is not so much with the pediatric population in the COVID era. Speaking towards, the bigger kids, if they're sitting 10, 11, 12, you're probably going to use it in exactly the same setup as an adult. You're just going to require the lower end of the flow rates. I don't know that I would be able to speak to the smaller kids, just because it's not something I deal with in ICU on a day-to-day basis. I know the very same question was actually posed to the UCL guys, and I think they had a similar answer to me in that, number one, they're seeing very few of the kids having COVID pneumonia as the problem. It was an incidental finding where the pathology was something else. So I haven't actually set it up at all to try it on a ped size. And the intention was always from my side, from my understanding, the intention was to always target more the adult population rather than the pediatric. But having said that, if you were looking at the smaller kids, you're probably going to have a lower threshold to move them onto a high flow type therapy and provide the CPAP in that form, that at least it's actively humidified gas for those kids. That would be my feeling. I stand to be corrected then.
There'll be lots of children that might not be COVID, but there'll be a lot of kids that are requiring oxygen supply from RSV or some of those conditions. that we do use non-invasive CPAP for, but we use the nasal prong non-invasive CPAPs, not the actual face mask. So we either use the nasal mask or we look at other options. So I assume that this machine, would it be able to have, what is the smallest face mask that would be available for it?
It's standard medical connection, so it's your 22 mil connector. So you can put any size mask you want onto it. The flow generator has a very wide range of flows. That first turn of the knob open will give you, or the first half a turn gives you around about, I think it was about 11 to 12 liters per minute that I'd measured. Your full rotation closer to 18 to 20. So if you're working at that low end and you've got an appropriate size mask with your kit, the same setup would work. You would just need to make sure that the PEEP valve and the filter are not too bulky that it's pulling the mask away from the face, which is why maybe configuring it rather as an HFNO for those kids is possibly a little bit more comfortable and a little bit easier to do.
Okay, thank you.
Any other questions?
Yes, Edwin Turton. Hello, Ollie. I would like to know, so do you need to use this with a flow sensor? I mean, or would you think that I would be able to titrate my oxygen concentration by looking at the adjusted turns of the knob?
So thank you. Very good question. It has been asked a bit. I almost forgotten to talk about it. So the one thing with this device is that your flow and your FI are independent. So the flow is set as flow, and then the FI knob just enriches it without changing the flow rates. So the primary thing to set up is always flow and make sure the patient is getting enough and that they're feeling comfortable, not like they're feeling starved. The UCL guys had used a flutter valve that they put on the expiratory limb. And they had set the flow that the flutter valve pretty much just stayed open throughout the respiratory cycle. What I found when I tested it the first couple of times is that you actually had quite a bit of wasted flow doing that wasn't necessary. Your worker breathing wasn't changed. You were still comfortable with slightly less flow using the 22 millimeter tubing as a reservoir, and that your actual inspired FI was relatively constant. So the flow is set purely to patient comfort. As far as the FI, the way that spindle knob works, it's pretty precise. Obviously, there's if you're turning a knob through a quarter of a turn and a quarter of a turn and a quarter of a turn, it's not ideal because you can't walk back to it and look at it and say, well, I'm still giving the same FI. Someone could have tweaked it a bit. So first prize is if you can have a portable. Let me get it here. Portable O2 sensor that you can just T-piece in and walk around and check everyone's FI that's been set. You can dial it back if it's too much, or you can increase it if you think it needs increasing. I mean, typically we set the FI based on the response in the patient. So irrespective of you measuring it, when you see that the patient is SATs are coming up and they're comfortable, we're in the right spot. If the SATs are way up at 100 and they look great, well, then you start dialing back on the FI. But it is nice to confirm what you're at. But if you don't have that, working through those quarter turns of the knobs, it is fairly precise. You'll be within probably 10 to 15% of where you think you are. But our greatest limitation at the moment, it seems, is to access the O2 fuel cells for these O2 sensors. The whole world is looking for them and you just can't get them. So we can't throw the therapy out just because of an inability to know exactly what number we're giving. Which is why if you have something to play around with, even your anesthesia machines, just play through the turns of the knobs. I've marked them so that I can see, and you'll get a feel as you turn through it exactly where the FI is kind of sitting. I don't know if that answers the question a little bit.
Thank you, Ollie. Yes, that answered the question.
Any more questions? Okay.
So if I can make one quick comment, one of the major concerns that has been raised by a lot of people is, isn't the flow too high? Aren't we going to have major supply restriction on our O2 supply? Yes, the devices are capable of, really impressive flow rates. At the top end, being designed by an F1 racing team, the device will achieve 140 liters per minute, which, if you think you're requiring that to give CPAP, I think you're definitely using the wrong therapy. So the idea is to, start low, work your way up until the patient's comfortable, enrich the oxygenation to a reasonable level, but also you need to identify very early who is a responder and who is a non-responder. It's where some of the early criticism came around with CPAP is that, well, it delays intubation of patients that need it, but not if you've really used it correctly. So there is a really, really nice presentation done by Mervyn Singer and one of his pulmonology colleagues from UCL, where they talk you through how they implemented it, how they used the device, a nice algorithm for patient flow through the hospital. So they arrived, they got, if their SATs were low, they got an O2 challenge with a rebreather mask. If they responded really well, they were then titrated down to a 40% FI immediately. And if they stabilized on that and they were comfortable, well, they carried on 40% FI. If they were poor responders, they then immediately got a CPAP challenge. And then again, you had a group of patients that responded well, in which case you then continued on your CPAP, and the average time on therapy for those patients prior to being weaned off was around about 4 days. The ones that responded poorly, they then had to decide, well, poorly or minimally, they decided were you a candidate for escalation of therapy, in which case off you went to ICU and potentially got a tube, or they decided that was ceiling therapy for you as you were potentially a poor candidate for critical care. And of the group, the cohort that it was deemed that was ceiling therapy, they salvaged about 25% of them just persisting with the CPAP. And at no point did they require ridiculously high flow rates either. They were working sort of at the bottom to middle end of the range, as Justin had showed. So it doesn't have to be a gas guzzler. It's only if it's used inappropriately. And if you look at the flow rates that you're going to use more often than not, you're probably using slightly less than you would if you were giving the same patient HFNO, because you're getting a greater end expiratory pressure with a closed circuit than with an open system.
Okay, thank you. Any other questions? Okay, maybe I can just mention that. So
can I just come in on?
Yeah, go ahead. We can't hear you. I'm not sure who's trying to talk.
Poncho, I was trying to talk. Can you hear me now?
Yes, we can.
Hello. Sorry, my internet is a little bit unstable. So just one comment on the flow rate. Set up in an uncontrolled manner. So just plugged into an oxygen port and dialed up. The amount of oxygen this thing can draw out is phenomenal. And a training issue that we're going to have to be sure of is that people are aware of the settings that Dr. Smith describes, and of unplugging and removing these things from oxygen, because we have already had some oxygen supply challenges.
Yeah, you're correct, Zane. I think the teaching and training is important, which is why if each of the guys that have got one now, sit and play around with it with yourself for a bit, you get a good feel of it. You can decide where you think its best application is going to be, and then kind of like a train the trainer scenario, pick a small core group of people that you can train, and then they start working with it, getting comfortable with it, and then they slowly train the next cohort. Even at UCL, where their staffing ratios are far better than we would normally have luxury of. They did extensive training over a relatively short period of time. I think they said they trained around about 100 staff members inexperienced in delivering CPAP therapy to deliver it. But then they managed those patients in relatively small cohorted areas that there was good oversight. And the training plus trying to cohort the patients and keep an eye on them meant that the therapy was inevitably given correctly, minimal wastage, and at least the patients got the benefit of it. And to me, if we're giving it correctly, this is exactly the device that is going to take the role away from the rebreather and the polymasks. Because any patient that fails therapy on a lower FI needs more than just oxygen. They need a little bit of extra support. So instead of having a patient sitting on 15, 20 liters of oxygen on a rebreather mask, we rather give them the same 15 liters of oxygen with a closed circuit with a bit of CPAP, and we should, in theory, get better effect.
Ali, in terms of safety, is there any alarm systems on the machines in terms of, if the mask is not correctly positioned, or does that have to be done manually all the time?
So look at
FiO2 levels as well. Is there any safety measures on the device?
There's inherent design safety in it. So that's why the circuit that is supplied has an anti-asphyxia valve that your patient will always be able to breathe, even if it's not always 100% FI or whatever you want them to get. If the flow is starved, they will still get air in, so they can't asphyxiate. It should always be used on an awake and cooperative patient. So that is your first alarm, and the patient, in theory, should be monitored to some extent, even if it's intermittently with SATs. There is no formal alarm system. Part of that is because as soon as you start adding extra electronic alarms, the regulatory requirements become a little bit harder. So it was design simplicity and inherent safety within the engineering design. So your patient on this device, even with the O2 control knob turned off completely, will never get less than around about 30%, and they will always get flow.
Thank you.
Okay, thank you. I just wanted to mention that so you will also either later this week or next week